It's great to see so many people here. I know a large number of you from meeting you in various places around the world, actually. What we'd like to do is give a little bit of background on how BACnet came into existence, and in particular, how the testing program got started and what the motivations were and what our thinking was along the way. This looks like a jungle, and what I was going to say was, if this is where it all began, it sort of looks like maybe BACnet crawled out of the primordial ooze in some jungle somewhere. But this was actually 1987 at the Opryland Hotel down in Tennessee, Nashville, yes, Nashville. It's a big state, you know. But BACnet really started years before, in a way, although it wasn't called BACnet at that point. In fact, it had no name. But at Cornell University, I had started working there in 1977. And we already had a rudimentary computer system. We had some digital communications to some dumb remote terminal units that allowed us to collect temperatures and pressures and statuses of binary points. And in 1981, Johnson Controls came along with their digital system controller 8500, the DSC 8500s, and said, hey, we have this new thing, it's based on microprocessors, wouldn't you like to use it? And of course, we had been using Johnson pneumatic controls more or less forever. So we said, sure, let's give it a try. And right away, the first question we asked was, well, you know, can it talk to our existing IBM System 7 computer? And they said, oh, no, you have to buy a JC 8540, our central computer, because that's the only computer that can talk to these Johnson DDC devices. Well, of course, since we could already talk to some other stuff, we said, well, you know, tell us how to talk to your DSC 8500s. Give us the protocol. And after much kicking and screaming and lawyers and all kinds of things, the highlight was when they said, well, if you implement our protocol incorrectly, you might blow up your buildings. And we said, yeah, but there are buildings. We can blow them up if we want to. So eventually, they gave us the protocol. It was delivered in a brown paper bag in the middle of the night. But we finally had the protocol, and we implemented it. And then other companies started coming around, Honeywell and Powers Regulator at the time, and other companies introduced DDC about that time. So it was obvious that even if we could implement all the different protocols, it would be kind of a frustrating fool's errand, because there'd be no limit to the number of different protocols that we'd be forced to implement. So I went to my boss and I said, you know, isn't there a standard? Isn't somebody developing a standard for this stuff? You know, I mean, they all use serial asynchronous communications, which was the way of communicating at the time through modems and things, RS-232 interfaces. So he said, well, go to ASHRAE. And I said, what's ASHRAE? No, I had never heard of it. I was a physics graduate, you know, I just never heard of that. So I went to Chicago in 1981. I went to a meeting of a technical committee called Control Theory and Application. And I sat there for 2 or 3 hours, and they never once mentioned the problem of interoperability or the lack of communication capability between the existing DDC systems. So to make a long story short, I joined TC 1.4. Tried to convince people that we really needed a standard. In early 1987, in January in New York City, the Standards Committee commissioned a standard project committee, 135P for proposed, and asked if I wanted to chair it. Now at that same winter meeting, Dave Fisher, who's sitting here, and I and a few other people went to a session sponsored by the Energy User News that was trying to figure out what was happening in the industry. And the energy manager of the year said, well, I don't understand why there needs to be a standard. We have ASCII and we have RS-232. So you should be able to communicate, and what's the issue? Well, we didn't try to explain it to that guy, but in that summer, we had our first meeting, and in the interim between January and June of 1987, I was sort of in the position as the newly minted chairman to select members to the committee. And it was sort of like Mission Impossible. If you remember Mr. Phelps, he had a stack of resumes and he'd go through them and he'd pick the guys he wanted on the Mission Impossible team. And that was sort of what I was doing, except that I didn't know the backgrounds except what was on the resume of the people that wanted to serve. But in the process, an ASHRAE gentleman introduced me to Steve, and Steve had this remarkable characteristic in that he was willing to serve as secretary of the committee. And if you've ever been on a committee and you've tried to chair it, you know you have to have a secretary who can take the minutes and tell what's going on later on. So Steve and I joined forces, and we decided a plan in advance for how this initial meeting was going to take place. And that was the key, really, to the entire process of developing the standard, because we were afraid that when we went in there, Honeywell would get up and say, well, just use our protocol, or Johnson would get up and say, just use our protocol. So we started out by saying, well, these were all gentlemen at the time. We were sitting around, we said, gentlemen, let's figure out what the characteristics of a good protocol might be. And so we had a butcher block pad of paper, and we started writing down the things that people thought were necessary for a good protocol. And after about half an hour, we realized, everybody realized, and that was the point, that there was not an existing protocol of any manufacturer or anyone else that met all these requirements. So the way had been cleared for developing something more or less from scratch. And so that's what we undertook at that point. But we needed to go further than that. This was an initial meeting, and we had decided that we needed certain working groups, and we called them working groups, not subcommittees, because a working group has the word work in it. And we wanted to make sure that some work got done between meetings. So we had 3 working groups that we formed. And by the way, if you want more details on the history, this is a self-serving promotion. I wrote this book a couple of years ago. And I took a lot of time to go through all the notes and things that I can't even remember today, but they're in here. Anyway, I had worked out with Steve that we would form these working groups upon a certain signal, sort of like a baseball game where the manager goes like this, when he does a certain thing, then the fix is in to steal the base or lay down the bunt or whatever it is. So when the time came, I said, okay, we need to now form some working groups to do specific things, figure out the character sets, the data encoding, what the messages are, and so on that we need. And I did whatever the signal was. I don't remember exactly, but Steve then made the motion that we approve the working group specs that had been drafted a single page each and passed around to the committee. And the best part of that was that many of the people that were on the committee at that point, and this was, I just didn't know who these folks were, so many of them were marketing guys, sales guys, there to protect the interests of their company and to see what could possibly come out of an ASHRAE committee. And so they weren't sure whether they ought to vote yes or no on the formation of these working groups because, they hadn't had a chance to talk to headquarters. So it was kind of like, the analogy I like to use is you have a dock and you have a motorboat idling next to it. And somebody has one foot on the dock and one foot on the boat. And the boat is revving and it's about to leave the dock, and these guys had to figure whether to jump on the shore or jump on the boat, and or get split in two. And as it turned out, they all jumped on the boat, and we had a committee and we had working groups, and that was the first meeting. And then we proceeded on from there. The press thought that this should be done in 6 months or a year. So the next meeting was in Dallas, Texas. And the press was there ready for the release of the standard, which they assumed we had finished in 6 months. And they were somewhat disappointed that the standard wasn't quite ready to go. But we began from that point and went on, and after many 8.5 years, we got to the point of publication in 1995. But before that, we were looking at the issue of, okay, we have this document. We have procedures, we have objects and services and data link layers and all these things. But, you know, we don't have any prototypes. You know, we need to have some hardware and some software that people have put together. And, you know, we were convinced it would all work, you know, well, but that there'd probably be some glitches and things that needed to be corrected or ironed out. And Steve was one of the main contributors to these discussions. So Steve, why don't you tell a little bit about what was going on at that point?
Sure. I'd like to back up to the first Nashville meeting for a minute so that people understand what the mood was like. I mean, first of all, this committee in ASHRAE, TC 1.4, was sort of the home of the best control experts probably in the world, certainly in the United States, and they've been doing this a long time. And I don't know of anybody who actually started placing bets, but I can assure you that had there been any bets, it would have been determined that the odds of succeeding were really long. All the people who really knew the industry and were the big lines in the industry were convinced that this could never succeed. Not that they thought it was bad, they thought it would be a great thing, but they didn't believe the companies would cooperate and work together. They didn't believe that we'd have the confidence in users. There was a lot of sort of negative feelings about it for that reason. And when we showed up at this meeting in Nashville, the tension was unbelievable. I mean, everybody's sort of looking and posturing at other people, trying to figure out what's going to happen and who do I have to protect. And there was one person who was particularly interesting to me who was on the committee. His name was Eno Kainlari. Eno was a professor of architecture at Iowa State University. He might have even been professor emeritus by that time. He was not a young guy. He didn't say hardly anything at this meeting, but he brought a sketch pad with him. And what he did was he looked around and tried to figure out who's going to be important in this group, and if he thought you were going to be important, he pulled out his sketch pad and he started sketching the faces of the people that he thought were going to really have an impact. And some years later, I reached out to try to connect to Eno to see if I could get copies of those sketches, but unfortunately he was in very poor health. And I reached his wife, but I guess he was suffering from dementia. And the bottom line was I never got the sketches. But the fact that he thought that was a momentous thing tells you a little bit about what the tension was like. And there was a lot of mistrust from the building owners about what the control folks would do because they hadn't been treated right. And that sort of feeds into why testing became pretty important.
Let me just say one more thing about the meeting in New York in 1987. There was a Region 1, which includes New York, New Jersey, and New England, had a regional dinner at the ASHRAE show, and I went to the dinner. People said, what is this thing about this standard for a protocol? You know, you guys, you're never going to be able to do this. It can't be done. And I said, well, why can't it be done? And they said, well, because the manufacturers are all going to oppose you. You know, they don't want it done. They have their people locked in, and it's not happening, you know. And I said, well, I know, we're gonna try. But throughout the 8.5 years of development, Steve and I went through some tough times when we got buried in public review comments and so on. And, you know, even up toward the end, we were saying, well, you know, they said it could not be done, and we haven't proven them wrong yet. So it wasn't until the standard actually got finalized that we could say, yeah, well, now it has been done.
So let's talk a little bit about some of the milestones along the way. So 1991 was significant because that was when the first public review of the standard was published. And it generated what for the day was a very large number of comments. And the other thing that was unique about it is they came from multiple countries. There was a lot of international interest in this. But that was also the year when I decided to start pushing to actually begin doing something about developing a way to do tests. Because now we had something that was firm enough you could start trying to figure out how to test. And although people thought testing was going to be a good idea, there was not a lot of enthusiasm for jumping into this because we had a lot on our plate already. And what really ended up happening was that Mike and I, Cornell University and NIST ended up identifying and buying a piece of hardware which was called a sniffer made by a company called Network General. And along with one of Mike's colleagues at Cornell, the three of us were putting together to build a BACnet protocol interpreter so we could actually look at messages on the wire and use that. So that was one of the first things that we did. Also, there was an individual from one of the large manufacturers who decided that their company would like to write some BACnet software to help them develop products down the road. And I decided to try to start writing some kind of a testing tool, so we agreed to work together. He started coming to our labs at NIST, and he'd come and stay for a few days at a time, and I was working on what I was doing, and we were trying to connect it together. So the first attempt to actually connect two different backend implementations was done by us in our labs at NIST. And this began to grow, and eventually, a couple years later in 1993, two things happened. One is people were coming on board that there was really some merit to doing this. And second, I work for the government, so there are political cycles that happen in the government. And at that time, one of the favorite things was to develop cooperative research and development agreements to show our relevance to industry. And so we combined these two things together, and NIST created such an agreement called the NIST BACnet Interoperability Testing Consortium. And we invited control companies to join, and the idea was that the companies would start building BACnet implementations, prototype products. We at NIST would work on developing this testing software and these testing methods. And we'd help each other out. We'd help them be sure their products worked, and the experience of working with them would help us try to figure out how to do testing. And that began in 1993. And it eventually grew to be 22 companies, I think is listed here. We had 13 HVAC control companies, 3 fire security system companies, 2 software development companies, 1 lighting control company, and 1 pump manufacturer. And a university, that being Cornell. And I think part of what's significant here is at the very beginning, this is several years before we had a published standard, we already had more than HVAC folks involved in this. I think that was a pretty important thing. Do you want to add anything, Mike?
Just that Steve's presence and the availability of the NIST lab was key, because we needed a place where people could come together that was seen as neutral, and it had the hardware and software to conduct the tests, and NIST turned out to be the ideal place for that.
So just for the record, these are the folks who were the members of the consortium. I think you probably recognize most of the names on this list. So, as we came closer to the standard being finished, it was finally published in December of 1995, and we wanted to prove to the public, to the building industry, that the standard could actually work. And we decided to leverage this consortium as a vehicle to do that. So the idea was that we were going to put together a booth at the ASHRAE AHRI show, which in that year was hosted in Atlanta in February. And we invited members of the consortium to commit to make a product or a prototype BACnet product that we would then connect and demonstrate in the booth. And we invited all the companies to join. Some did, and some were not in a position to do so. And the idea was to use every LAN technology that was defined in the standard. We wanted multiple workstations. We wanted, a spectrum of different kinds of controllers. And we went through a process of qualifying the companies to be able to be in the booth, because of course we wanted this to work. So the first thing that happened was we did one-on-one individual testing in our labs at NIST to be sure that the products seemed to be conforming with the standard. Then we did a series of tests where we brought all the products in that were going to connect on the same LAN technology, so we could do plugfest type work with that LAN technology. And then finally we did a dry run or two with everything interconnected together. And then the result came out as this big show at the booth at the ASHRAE meeting in February of '96. And this describes the network topology of what we put together for that. Do you want to say more?
We'll get back to the network topology in a minute, but notice that we do have Ethernet, data links, ArcNet, MSTP, and LAN talk all allegedly happily playing, and we'll get to that in a minute.
Okay. So here's a photo of the booth. And you can see, it was a very popular booth. There were people, it was just filled. This was sort of a low time here, but this might have been when we were getting ready for some things. I can't quite see it from here. Did you want to tell what happened in the booth?
Yeah.
Okay.
Well, there are a couple things here. One thing is this logo, Your Connection to the Future. That was devised by a marketing guy from Train by the name of Paul Ehrlich. How many people know Paul? Some people know Paul. Anyway, he was creative and came up with this, and I believe that sign is now in your lab, isn't it?
It's still there.
Yeah. And we had, each vendor was given a column on which to place their equipment. And people that came by the booth were astounded because imagine, you could be in a booth and you could see in the same booth Train and Landis and Gear and Honeywell and Johnson Controls, all in the same booth. This was in an era when competition was just unheard of. But the thing I really want to point out is these two guys down here that are on the floor. And they've got basically a luggable with a protocol analyzer on it. They're trying to figure out why some of these devices can't talk to each other. Now, any given device could talk to several other devices. And so it was kind of a strange situation where one device could not talk to a device further down the line, but that device could talk to the ones on either side. And after much toing and froing and engineering work down here on the floor, we finally figured out that there's a difference between the coax cable used for ARCnet, which is 58 ohms, and the coax, the Ethernet is 58 ohms, and the coax for ARCnet was 78 ohms. And the cables were slightly different. But the impedance mismatch caused reflections and bouncing back and forth of signals so that there was destructive interference of the signaling between certain pairs of stations that wasn't present between other pairs. So it worked fine between certain of the controllers and not correctly between others. And it all turned out to be a matter of an improper piece of coaxial cable that somebody had run. So once we figured that out, changed out, the booth, I can say, worked flawlessly in the end.
The last note here, I think that we have another picture of it on the next slide. Yeah. So during this process, one day.
By the way, the standard was published in '95.
In '95, just before the coming out party. One day, my boss comes into my office and he sees me working away on something, and he says, "What are you doing, Steve?" And I said, "Well, I'm writing some code for this testing software tool we've been working on." And he said, "Steve," he said, "I don't think you should be spending your time on that." He said, "There are a lot of people that can write code, but there are other things that only you can do, so I think you should find someone else to write the code to do this." And that ended up resulting in me actually reaching out to someone on a contract basis to continue the evolution and development of what had not yet been named, but later came to be called Visual Test Shell, and that was actually Dave Fisher and his company. And he got involved, and so we had the first release of that tool in 1997. It was on the previous slide. That was the first publicly available tool that anyone could get and download and use to do BACnet testing. And there was a second version that came out a year later in 1998. And in 2000, so we also began, I don't remember what year it began, we don't have it on here, Mike, the work on the 135.1 testing standard. I don't remember. But we started documenting all along the way of how we were doing these tests, and my documentation of that led to the first draft of what became standard 135.1 method of test for conformance to BACnet. And that actually came out for public review in 2000, according to this, which I believe to be right.
Right, and it actually finally was, finally published in 2003, which is maybe on the next slide.
Right, and back in 2001 was the very first time that there was this attempt to launch BACnet testing and listening programs. And if you think about this, so we started this in 1991, In 2001 was the beginning of the real effort to make a testing and listening program. So we've been working at this for 10 years, you know, by the time we got to this point. So one of the things that came up, you want to talk about the formation of the BMA? I think you wanted to.
Yeah. A number of things were going on, of course, in parallel, one of which was work in the international community. And today, BACnet is an international standard. It's ISO 16484-5. Steve and I know this because we were just over in Oslo working on that committee's efforts to keep the standard going internationally. So there was work in the international arena, but another whole area of interest was how do we promote BACnet amongst the user community and amongst the other manufacturers. And in 1998, a group of people here in the States wanted to form, and they were all college and university people, wanted to form a user group or an interest group. The result of that was what was called Big North America. We weren't sure whether to make it Big BACnet Interest Group, colleges and universities, or, you know, Big US or Big Canada or what. So we came up with BACnet Interest Group North America. That was 1998. The following year, in 1999, a group of the manufacturers got together in Colorado and discussed the formation of a manufacturers association because they were concerned, among other things, about the lack of a testing program at that point. And the result of that was the formation of the BACnet Manufacturers Association. And it was formed not in February of 200, but of 2000. Factor of 10.
We're old, but not that old.
Yeah. So the BMA's focus was very clearly on testing, and that was what all the initial efforts were poured into. Now, Steve and I in particular were looking for a broader portfolio of things for BMA to do, like education and marketing and other things. And so the BACnet Interest Group North America and BMA coexisted up until 2006, when it was decided to form BACnet International. So there were a variety of things going on. In 1999, or 1998, the beginning of 1999, the BACnet Interest Group Europe formed in Frankfurt. And so it was the very first BACnet Interest Group. The folks wanted to call it, because they were familiar with the LAN users group, they wanted to call it the BACnet Users Group, or BUG. And I tried to explain to them that in the English language, bug and computers were not good things to be in the same sentence. So they agreed that they would change the name from BACnet Users Group to BACnet Interest Group. And that was the very first BACnet Interest Group that was formed.
So here's some pictures. This was the very first Plugfest hosted at my labs in NIST back in 2000. You can see some photos. You can tell the dates by looking at the computers, you know, that are in the slide. And it was a pretty exciting thing. So this was the first time that we had such a Plugfest. And you may even recognize a couple of characters in there if you can imagine what we looked like when we were young. And you mentioned this already, about the formation of the BMA and BI. So the BACnet Testing Lab came into being, you know, with the formation of the BACnet Manufacturers Association. And of course we had to have a logo for that because we wanted there to be some identifying mark that could be used commercially. That was an interesting little process that we had to go through to do that, because BACnet had been trademarked by ASHRAE, appropriately so, and you can't use it without permission, and ASHRAE was sort of reluctant to be involved in testing and certification or anything that looked like that, because it was a professional society, you see. And so we had to deal with the ASHRAE staff and ASHRAE lawyers, and we finally got permission to create this logo, which you're all familiar with. And part of the logo requirement was the part you can't read at the bottom.
This bullshit down here.
You know, the lawyers insisted that we had to have this kind of a thing down there as a protection for Asher. And we pointed out, okay, but it'll be so small you won't even be able to see it when you try to put it on a product and so on. So there was eventually permission to take it away under certain circumstances, but you know, that little language down at the bottom is a product of a lot of lawyers being involved. Is there anything else you wanted to say about that?
That's good enough.
And then by 2003, we finally finished the task of publishing the first version of Standard 135.1, the method of test for conformance to BACnet. And here's sort of a look at what the current cover design looks like. I think it was slightly different in 2003. This is a slightly newer version. But so remember, we started in 1991, and in 2003, we finally had the very first published testing standard. So it was a long slog.
And there's a new version out for public review right now, I believe. Isn't that right?
What was that?
135.1 is out for public review now.
Then in queues.
Yeah.
So hopefully 2019.
Not the full thing.
No, not the full thing. Not yet.
Well, I think it's time to show these things.
Yeah. Yeah, let's talk about BACnet hats.
There were some interesting marketing campaigns that came out in the early days of BACnet, and one of them was a company that sort of decided to do something like an FBI or a federal agency, you know, ATF or one of those groups. They had these coats, you know, with this big phrase across the back, BACnet, a force to be reckoned with, and then the next year they came out with hats, or vice versa. I forget the order of the things, and so this became part of the marketing, and the hat became famous because we would carry it around the world to our international meetings and various talks that we did, and we'd use the hat and we'd place it in some place that was symbolic of whatever city we were in, and take a photo. And if you go to the BACnet website and look at some of the old news, you'll see pictures of BACnet hats in lots of places, like the Australia Zoo is one of them.
The Great Wall of China.
The Great Wall of China. The Little Mermaid in Copenhagen has a BACnet hat. I mean, there are many of these things. But my favorite BACnet hat
camel in Dubai.
Yeah, camel in Dubai. My favorite BACnet hat picture is this particular one. And I can date this by the age of the little girl here. This would have been taken about 1999. And she's just beginning to walk. And it says, you know, a force to be reckoned with. And to me, this sort of symbolized, that was sort of the fledgling early days of BACnet. But it's grown up. This is what she looks like more or less now. And I think it sort of shows that BACnet in the same way has also grown up. And you know, there's a couple people in this room who've met this young lady, and I can tell you and they'll agree that she is a force to be reckoned with. But it shows how BACnet has grown and matured, but it also, to me, suggests that there's still a long ways to go. Just like this young lady has a lot of great things to do and growth in her life, BACnet is the same way. So to me, this is a pretty good analogy for where we come from and where I think we have the potential to go in the future for BACnet. And you guys are all a really big part of that, and it's pretty exciting to see.
Yeah, I was going to say that the title of this talk was supposed to be the importance of testing, or something like that. And I just want to reiterate that indeed, without comprehensive testing, BACnet would not be where it is today. And the reality is that everybody in this room is contributing to that success. And so it's critically important that we continue with PlugFest, that we continue working together to refine the testing that we do. And I just want to personally thank everybody who's taking the time and the effort to participate in this event and throughout the year in the testing process, because without that, BACnet simply wouldn't be where it is today. So testing is critically important, and you guys are critically important to the success of BACnet testing. So thanks very much, and I think that's pretty much it.
I thought of a story that I would forget to tell.
There are lots of stories, by the way.
But this is relevant to the way that the consumers see the importance of testing, and why it managed it. There was a very large project we were involved with, which was the world's first large-scale multi-vendor BACnet project. It was done for the U.S. General Services Administration. And they literally had a team sitting outside the door of the meeting where we were voting to approve BACnet for publication to see if it would happen, so whether they could undertake this project. So,
San Diego.
And the meeting was in San Diego. The building is in San Francisco. It's called the Philip Burton Federal Office Building, but it's mostly known by its address, 450 Golden Gate. So I'll skip over a whole lot of details, but we're in the process of commissioning the system that would go in there. And the guy who was the project manager was a fellow named Joe Olivier, who worked for a company called ESS, I think it was.
Yeah.
But in any case, there was no testing and certification of BACnet yet. It was still several years away, but we've been doing testing in our labs to qualify things, and we've been working with the manufacturers to be sure they configure things. Mike and I have taken occasional field trips out to look over their shoulder.
We formed a team called the Strategic Network Operations Team, or the SNOT team. We were the ones that sort of oversaw the project.
But the point is, the vendors were all putting their piece together sort of independently, and we came to the day when it was to all be connected and turned on. Now, Joe was kind of nervous about this. Now, he didn't tell us this right away, but we later learned that he had cleared his schedule for 3 days in order to deal with the chaos of problems that were going to ensue when we started trying to connect all this together. But what really happened was we made all the connections, we powered everything on and turned it up, and it worked at the very beginning. There were no issues at all because we had tested things, we had done our preliminary work, and everything communicated and worked flawed. He was absolutely dumbfounded. And this is a guy who believed in the technology, he was really working in this, but like most building owners, probably all building owners, they didn't really believe yet in the technology, and they didn't believe that testing would really help to make sure things were right. But I think that was a great example that if you do the right testing and you pay attention, it really does have an impact.
Okay, thanks very much, everybody.
Thank you.